We're going to solve this equation right here on the interval from 0 to 2 pi, which is the directions I refer to as like part A of a problem, of a solving trig problem, 0 to 2 pi. Now here, we just had a conversation a few minutes ago about, when are we supposed to be using identities and like trying to square and get those squares in and plug them in. Here is an example where we want to use identities to help us solve. We're not verifying. We're not trying to prove that this does equal 0. We're trying to figure out when it equals 0, because it only equals 0 for certain angles. And right now, a red flag is that I have cosine in my problem and sine, and that's what makes it a little harder. We want to try to get this to be just one type of trig, just sine or just cosine, if we can. Now, in your brain, you should start thinking like, oh, I know an equation, a trig identity that involves sine and cosine together. That trig identity is the Pythagorean identity. There's 3 different iterations of it. Identity. There's 3 different ones, but the original, the OG Pythagorean identity was sine squared theta plus cosine squared theta equals 1. Okay, right there equals 1. So what can I do to kind of take care of this equation so I can get rid of one piece and make sure that what I replace it with no longer has that in it, but involves the other trig function that I can't really get rid of. So this one here is to the first power. I can't really get rid of it. I'm sort of stuck with it. Okay, so I can't get rid of sine. Then I'm going to try to get rid of this guy, cosine squared. I happen to know cosine squared exists inside this Pythagorean identity. If I isolate cosine squared in something I already know to be a fact, it'll just make me a new fact. Identity means fact. So I'm going to subtract sine squared theta. These are facts we're allowed to use, okay? Like in geometry, point, line, plane, those words were defined kind of right at the beginning of the year. And then you use those words to define other words and other different things in geometry. So it's kind of like that. These are things that you're given. You're told these are rules, facts, you're allowed to use them, and we use them to do other things. So I have cosine squared theta equals 1 minus sine squared theta. I'm going to take cosine squared theta, which happens to equal 1 minus sine squared theta, and I'm going to use substitution. I'm going to substitute that in right there. Then I get one step closer to my goal. 1 minus sine squared theta plus sine theta plus 1 is 0. So this already is starting to look like a quadratic type of equation. So I'm going to combine like terms and I'm going to put it into standard form or descending exponential order. So this will be first. So the 1 will combine with that one. So I'll have negative sine squared theta plus sine theta. And then this was a positive 1 and another positive 1, so plus 2 is 0. I don't like having a negative leading term when I have something in a quadratic style. Again, quadratic style looks like ax squared plus bx plus c. And I would prefer if a were positive. So I'm going to go, and you could call it multiply or divide. I'm going to divide everything by negative 1. And all that's going to do is flip all my signs from negative to positive, positive to negative. So what am I going to get? I'll have positive sine squared theta minus sine theta minus 2 is 0. My coefficient here is a secret 1. My coefficient here is a secret 1. So if I were thinking of it like this, ax squared plus bx plus c, then I'm thinking of it as 1x squared minus 1x minus 2 is 0, So that's in your thought bubble a little bit, and you could factor that. So if you need help with factoring still, if you ride that struggle bus, I do have a bunch of videos on factoring. I was trying to include them in the description box under the videos on YouTube. So if you look there, if you scroll down, it should say like need help with factoring, and I have a bunch of factoring videos. So if you need help with that, they're there. Even specifically trig and factoring are there. I'm not going to go over that right here to save some time. If you factor, I promise, whether you use AC method, if you use your own guess and check method, go nuts, you would get, but I'm going to go with the trig right away. So I'm going to have sine theta, sine theta. I'll have a 1 in one of them, a 2 in another one, and minus 2 plus 1. I think it's something like that right there. And if I check, first times first, sine squared, good. Outer is negative 2 sine, plus 1 sine is negative 1 sine, good. Last times last, negative 2, good. Okay. Now what we use is basically the zero product property. And that means, I'm just going over here with a little arrow, I set each factor, sine theta plus 1, I set that equal to 0. And then sine theta minus 2, set that equal to 0, and solve those independently. This is really saying then when does sine of theta equal negative 1? Between 0 and 2 pi, there's only one place, one angle. Remember, theta is an angle. There's only one angle where theta equals negative 1. And here I want to know when does sine of theta equal 2, or 2 over 1. So if you want to say, you could say, you don't have to participate right now because this is after class, after hours, but negative 1, sine equals negative 1, where? So think about it before I write it down. Negative 1, y value, unit circle. Think about the circle in your head, origin. Negative 1 for y is down 1. What angle is that down there? So the answer, should have thought, is 3 pi over 2. And then here, this should make you think of an example we did, and I can link this one at the end of the video, but this one, we went into a big explanation about what happens in a certain situation, and if you need that explanation, you're going to click at the end of this video, a little card will pop up, a little thumbnail of the other video, click that to get that lesson, little explanation on why I'm writing no solution for this. So this part of my equation gave me no solution. This part gave me one solution. So if I only want answers between 0 and 2 pi, I'm done. If for some reason, you know, we wanted all solutions, all, then you would just basically give me every answer that overlaps that. I could write theta equals 3 pi over 2 plus 2 pi n, comma, n is an element in the set of integers. Okay? Hope that was helpful for you. That encompassed quite a bit. And if you are happy and good, thumbs up. If you're not happy, not good with this, thumbs down. And if you need that explanation on why that's no solution, which hopefully you watch it, just click on that. I'll post it at the end of this video after I get it all uploaded and organized. Okay? Thank you. Have a good day.